So I wanted to make a hopefully quick video for my puzzling passage since I couldn't really explain it 100% in words, so I thought this would be a little bit easier. But in Academy 285, right around the beginning of section 13, Kant says, if two things are quite equal in all respects, as much as can be ascertained by all means possible, quantitatively and qualitatively, it must follow that the one can in all cases and under all circumstances replace the other, and this substitution will not occasion the least recognizable difference. This in fact is true of plane figures in geometry. And then he goes on to talk about how three-dimensional figures is not true, basically. But I wanted to say that I think that he was taking for granted the fact that you can do this with two-dimensional figures. So what I have here is two triangles. They have the same exact length, same height, same length of the hypotenuse. All the angles are the same. We kind of have them on an X and Y axis here. But he's saying that if basically all of the aspects of a figure like that, they have all the same length, width, height, angles, they should be able to replace one another in space. And that's true of two-dimensional figures. But something like this, if you were to just utilize your X and Y axis, and you're only doing this in two-dimensional space, you would never be able to make these figures overlap, right? So you can do this as much as you want. You're never going to be able to actually get these figures to replace each other in these two dimensions of space. Not until you basically have to flip this across the y-axis. Now we do that in geometry all the time, but you basically, if you're to actually do that, you are bringing your triangle out and across a third axis of space, right? The z-axis at this point. It's coming out. So now we have just these two right now, but now it's coming out onto a third dimension in order to actually be able to cover up this shape exactly perfectly. So I only do that to say that I think that in order to do that for two-dimensional space, you're basically having to utilize a third dimension. And I think maybe he was taking that for granted. Anyways, thoughts?